Hello and welcome. We have a new problem to solve that tells us motion of a charged particle in gravitational and magnetic field. The problem is in a terrestrial laboratory experiment. That means it has been done on the earth, and apart from other forces, the force of gravity is going to play its role. We have to take under consideration the gravitational force. A small body of mass m and charge q is released in vacuum in a horizontal homogeneous magnetic field of induction B. We can assume that mg is less than qbc, where c is the speed of light. We will consider its implications later during the problem. So the next line reads, the motion of the body is examined until it reaches its deepest position. It's all right. And there are few problems related to this. The first one is, what will be the maximum velocity of the body? And how deep will it sink? This is the second problem. Third is, what is the average velocity of the body in the horizontal direction? And what is the acceleration of the body at the deepest point of its trajectory? So there are many more problems to solve, and we need to find out the maximum velocity, the maximum depth it traveled, average velocity in horizontal direction, and acceleration at a particular point. So we have targets defined. What can we do? Velocity and displacements are relative terms. Velocity and displacements are the terms we need to explore, we need to find. So it will be good to use the mechanical energy conservation or the work energy theorem here. And usual Newton's second law of motion will be into play. And there we need to find out the acceleration. So Newton's laws of motion naturally appear in the solution, and I don't see many more things to use while solving this problem. So I'm going to solve it. But first, I will need to form a coordinate system. And let us assume a coordinate system whose x-axis is horizontal, as you can see in this picture. Yeah. And y-axis in vertically downward direction. G will be positive, of course. And the magnetic induction vector is also horizontal and directed into the plane of the paper. I've just assumed it. So it will provide our z-axis, and that charged particle starts from the origin, right from here. And I have drawn a curve schematically like this, along which this charged particle can move. And The motion of this charged particle obviously takes place in xy plane. So what do we need to work first? I think I'm going to find out the force acting on this charged particle. And so now so I'm going to write down, since the total force acting, the forces acting on this charged particle are magnetic force, that will be q v cross p, and the force of gravity, that I would like to write it as mg vector. Now, since the motion takes place in xy plane, so velocity vector can be simply written as vxi cap plus vy j cap, and the magnitude of velocity is simply under root vx square plus vy square, and magnetic field vector is simply vk, and g vector can be written as gj cap. So writing in this manner, I can write the force equal to q vxi cap plus by j cap cross bk cap plus mg j cap. And now I can look for x component and y component of the forces. X component of the force you can see here is simply q vy p, and similar manner y component of the force can be written as mg minus q vx b, and so x component of acceleration can be written as qb by mvy, and y component of the acceleration can be written as g minus qb by mvx. Here qb by m, focus on this term qb by m. This term has got dimensions of circular frequency. This quantity is called the cyclotron frequency, because it is the circular frequency at which q by m, a specific charged particle, moves in the cyclotron in the B, that is magnetic field. So AX can be simply written as AX equals omega naught. I am going to write this circular frequency. Omega naught is simply QB by M. So I am going to write AX as omega naught Vy and Ay equal to G minus omega naught Vx. And now we need to move further, but I'm going to put these equations right here on hold because I want something else. Use work energy theorem first, and since we can write the work energy theorem for the motion of this charged particle, starting from the beginning of motion when its velocity was 0 and it was at the origin, and later it was an later considering an arbitrary moment when its velocity will be v, and since the Lorentz force is perpendicular to velocity, so it doesn't work. So it is sufficient to calculate the work done by gravitational force only. So work energy theorem can be written as work done by gravitational force for the displacement y, that will be equal to change in kinetic energy. And since its initial speed was equal to 0, we can write half m the kinetic energy when its displacement becomes y as simply and velocity as v. We can simply write it as vx square plus by square. This is the work energy theorem for this. And we can observe one thing. The speed of the body will be maximum. Here, this whole term is v square. So speed of the body will be maximum when vertical displacement y is maximum. And call this maximum velocity of maximum displacement of the particle along y-axis as y star. Let's find the v star. V star, the velocity, the maximum velocity of the object, of the particle. And y star is maximum displacement along y-axis. So at that moment, Vy will become 0. The vertical speed is 0 at the maximum depth. So only horizontal component of the velocity is present, and call this velocity as Vx star. Then we can get as Vx star will be simply equal to under root 2g y star. This is one equation we got. And now we can use this equation as well. And writing this Ax as dvx by dt, and omega naught will be there, and Vy as dy by dt, and cancel out dt from both sides. We can write the equation as dvx equals omega naught dy, and putting the limits of this right hand side variable y from 0 to y star and vx from 0 to vx star, we can simply get here vx star is equal to omega naught y star. So we have two equations here for Vx star, and now we can compare these two equations for Vx star, and we will try to get something. And we have two equations. Vx star equals omega naught y star, and Vx star is also equal to under root 2g y star. And now if you want, you can calculate the value of Vx star simply as 2g by omega naught. You must calculate this, and if you wish, you can put the value of omega naught here so that your result will become 2mg by qb. This is the value of omega star, and in the similar manner you can calculate the value of y star as 2g by omega naught square. And after putting the values of omega naught, you will get 2g m square by q square b square. And I think First two parts of the problem has been solved. Now we can consider one more equation we have earlier obtained, and that was ay is equal to g minus omega naught vx. And if we elaborate this equation, we will have simply dvy upon dt equals g minus omega naught dx upon dt. And this equation can be further written as dvy equals gdt minus omega naught dx, and we can integrate them. And dvy is, since 0 to 0, from the moment of a start till the particle reaches to its maximum depth, maximum sink. And the time for the moment, I would like to write it as t star, and x as simply as x star, and it was initially 0, and I will get the result as 0 equals gt star minus omega naught x star. Let's see what it tells us. It tells us this equation. This equation, we can get the value of t star simply, and the value of t star here we will get equal to omega naught x star upon g. And now we can get the value of average velocity in horizontal direction as horizontal direction. The average velocity in horizontal direction is simply delta x is x star only, divided by time taken is t star, and you are going to get it something like g upon omega naught, and its value is simply mg by qb. And this is it. This is the average velocity in horizontal direction. But there was one more problem. We have to find the acceleration of the body. Acceleration of the body at the deepest point. And we can use the same result here as ay is g minus omega naught vx. And at the deepest moment, we have written everything as a star, so ay star can be written as g is constant omega naught minus vx star. And we know the values of everything here, and we can put here the value of g is given, the vx star we already got, and it's going to be something like g minus omega naught is qb by m. Vx star was nothing but it was 2mg by qb, and the values we got is g minus 2g. This term has become g minus 2g, and that is equal to minus c. That means the charged particle accelerates vertically upwards, just as the acceleration of just with the acceleration g. And well, I can provide another solution for this, and I'm going to provide in the next video another solution for the same problem. So thank you very much for watching up to this end. Sorry.